My name is Shanshala Vijay from grade 11A, and in this video I'm going to talk about the Planck principle for this physics practical test for this semester. So, the Planck's principle was actually first measured by Joseph Planck, a Scottish physicist and chemist, hence why the name is Planck's principle. But the real question is, what is the Planck's principle? So, the Planck's principle is when the amount of heat energy given by a hotter substance is equal with the amount of energy that is received by the cooler substance. So, for example, if we mix hot water with cold water, the cold water will absorb all the heat released by the hot water until it reaches an equilibrium, or specifically thermal equilibrium. And now let's go to the example. So before going to the example, let me just tell you that the Planck's principle formula is Q release equals to Q absorb, and the formula for Q, or heat, is equals to mass multiplied by specific heat and then multiplied by the change of temperature. So here is an example of problem related to the Planck's principle. And before answering this, we need to find the known information. So let's just write known. So we know that the mass of iron equals to 1 kilogram. So 1 kilogram of iron, and the temperature of iron is 100 degrees Celsius. 100 degrees Celsius, and the mass of water is 2 kilogram. Well, the temperature of water is... okay, so there has been a mistake. There should be a temperature of 20 degrees Celsius. Let me just fix up the temperature of 20 degrees Celsius. So what's the final mixture? So we know that the temperature of water is 20 degrees Celsius. Specific heat of iron, 450 joules per kilogram Celsius. Specific heat of water, 4,200 joules per kilogram Celsius. And so we need to find the temperature of the final mixture. To find the answer, we have to use the formula of heat release equals to heat absorb. Iron has a higher temperature than water, so the iron releases heat and the water absorbs the heat. So that's iron and that's water. And now we can just write down the formula of Q. Reminder that delta T is the change of temperature, so we cannot just directly put the number of temperature, for example, the iron temperature or the water temperature, directly into the solution. So here it is, the change of temperature of iron and the change of temperature of water. For iron, it's 100 minus T, and the water is T minus 20 degrees Celsius, because T is the final temperature, and T is in the middle of the hotter substance and the colder substance. So that's that. And now let's continue. We can just replace the formula with the numbers that we'll have written in the known section. So for the mass of iron, it's 1 kilogram multiplied by 450 and delta T, which is 100 degrees Celsius minus T, equals to 2 kilograms multiplied by 4,200 for the specific heat, and T minus 20 degrees Celsius. And we can just multiply it. Multiplied by 100 equals to minus 450 T equals to 8,400 T minus, oh my god, this is kind of confusing. 8,000. 168,000. And then we move this minus negative 450t to the right section and remove the negative 160 blah 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 to the left section. This equals up to 213,000, which is 8,850. We can just simplify this by dividing this with 8,000, and it equals up to 24, and the unit is obviously degrees Celsius. The final temperature of the mixture of hot iron and cold water when both are in thermal equilibrium is 24 degrees Celsius. So that was my explanation for the Black's principle. Thank you for watching.